So let's look at question 1 first. So for question 1, what are we asking? What are we required to find?
Total amps.
We need to find the total amps. So IT. To do that, what don't we know that we need to know?
Resistance total.
We don't know resistance total. So we need to find a strategy in which we can break down this combination circuit. We need to break it into manageable sections and then find our total resistance. So the first thing I would do is break it up into the following segments. I would call that RA. Okay, how are those resistors connected?
They're on the same wire.
Which we call series. So RA equals, we can call this one R1 if you want, R1 plus R2. Happy with that?
Yeah.
Once we've calculated that, we need to create another segment which we will call,
RB.
very creative, RB.
I want to roll the answer to your question.
How are those resistors connected?
Parallel.
So we would write the parallel equation. 1 on RB equals
R1. 1 over R1.
1 over RA.
RA.
1 over RA plus 1 over
RB.
R3. Let's just call this one R3.
3 and P.
Okay.
One.
So it's just about filling those values in. Once we have that, how is the 6 ohms connected to RB? It's in series. So our final answer, RT, is going to equal 6 plus RB. If you've gone through those steps, you're probably in the right place. I'll add some numerical values so it's not just purely in our head. So to calculate RA, it'll be 6 plus 14, which equals
120.
20. 1 on RB equals 1 on 4 plus 1 on 20, which equals 5 on 20 plus 1 on 20. And as we are not fraction fearers, we know that RB equals 20 over 6, which equals 10 over 3. Good? RT therefore will equal, over here, I'll just put the lines into sections so we know what we're up to. RT equals 6 plus 10 over 3, which equals 18 over 3 plus 10 over 3, which equals 28 over 3.
I've still got a fraction at the end, so I just got the wrong fraction. Yep.
Now that's our RT. Are we at the right place yet? What do we need to do now?
I do the V equals I.
V equals IR. I'll do it over in this red section because I'm running out of room. And I'll do this in red so it's clearly different. V equals IR. Do you want time to fix that up or not? I can give you some time. You can't fix it up. Okay, it's beyond fixability. 18 equals I times 28 over 3. And then if you divide both sides by, well, what you can do is times both sides by 3. Divide both sides by 18, 28. And we get a fraction. I equals 4, carry the 2, 64 over 28. Oh, that's not how we carry the 2. 54 over 28, which we can simplify. 27 over 14 amps. Cool. You got that? Well done. It's really important, just trust me going forward, it's really important that you're able to use fractions. So yes, I know these questions are a little bit gross, I set them up to be that way, because if you don't use fractions well and you're using decimals, you get yourself into trouble. Do not need a calculator for any of that. And unfortunately, the going rate in senior, particularly in math methods, which most of us will choose, is that half the exams you do will require tech-free. So you need to be able to deal with fractions. So the more exposure, the more practice we get, the better we're up to. I'll leave that one there, but what do we ask for?
Resistance.
So we need to find the resistance.
How
How are we going to find that resistance? How are we going to get that? What do we know?
We know that amps,
So we know total current.
Yeah.
What else do we know?
volts,
Total voltage. So we can find the total resistance. Once we know the total resistance, we can find the resistance of our parallel. Well, the only thing in it is a parallel circuit, correct? So we know the total resistance, which means we can find this section here. Just be aware, how are these two connected?
series.
In series, so you might have to think about that when you approach that problem. Once you've got your total resistance, you need to find your current on your top branch and your voltage used by your second resistor. Cool? How do we know we're finding voltage in this one? On the red, how do we know we're finding voltage? How do we know we're finding it? Because of what?
Because it goes out.
Yep, which means it's in. This is series, so current's always measured in series. Voltage is measured in parallel, even though I haven't put